Video. We are going to solve exit point in a matrix. In this question, you are given a matrix of size n cross m, and number of rows and a number of columns, and they are filled with two numbers, either 0 or 1. Okay, we will start from the top left position, which is 0 0. Okay, and we'll move in left to right direction. Now, whenever we encounter a 0, whenever we encounter a 0, we will keep the same distance, same direction. We'll keep the same direction. Okay, but if we encounter 1, as in the case in example 1, in the index 0 comma 1, when we encounter 1, we'll do two things. We'll change the direction towards right. We'll change the direction towards right, which means from 1, sorry, 0 1, we'll come to 1 1. We'll move in the right direction, which is downward in this case. And we will also do, we will exchange this 1 with 0. We'll swap this 1 with 0. We'll do two things. When we encounter 1, change the direction to the right, towards the right, and change the value of 1 to 0. Okay, and in this way we will traverse in the matrix, and at the end we'll again reach the exit value is what? The, like, we started from 0 0 in example 1. We encountered 0, we move in the same direction rightwards. We move to 0 1. We encountered 1, change it to 0, move down rightwards, which is down in this case. Again we encountered 1, okay. Now change it to 0, swap 1 to 0, and move the right direction, which is leftwards in this case. I mean, in the leftward, yeah, because we were moving in downward direction, so right will become left in direction. We'll come to 1 comma 0, and since we encountered 0, we'll keep the same direction. And if we keep the same direction, we will come out of the matrix, because we are moving in the leftward side this time. And this and the index from which we came out of the matrix is what is our exit point. So we'll return the index 1 comma 0, 1 comma 0, which is our answer also. So let's not waste much time and see how we can do it. It is very easy question, since it may seem that we are doing a lot of things, but it is quite easy. A lot of if else cases, conditions to cover. So first condition, we start the loop I, which is less, I mean, starts from 0 and goes till n, and apart from that, j, which also starts from 0 and goes till m. Okay, so we have defined the bounds, and will check if the matrix ij is 1 or not, because we only need to do things when we encounter 1 in the matrix cell. Otherwise 0 will keep the same direction, we'll keep on moving. Okay, we don't need to change anything. But if we encountered 1, first of all we'll swap the value of this cell with 0, and then we will define in which direction we will need to move, okay. So this will define in which direction we will need to move. Okay, move plus one step and mod by 4. So this will define in which direction we are moving. Now we'll check if this movement came as 0. Okay, because it means we have already encountered some values in this direction. We'll move downwards, as was the case in the example 1 also. We'll move downwards. Now else else if this movement, this mv value is 1, value came 1, in this direction we'll need to move rightwards. Okay, now apart from that, if this value came 2, value of mv movement came 2, in this direction we'll move upwards, so reduce j by 1. And else if mv is 3, in this case we'll move leftwards. Cool, reduce I by 1. Okay, now that we have defined the movements, in case we encountered 1, we'll see in this direction, and we what is the exit point. So it will keep on moving in the loop, in the matrix. Now we need to find in from which point we are moving out. So at the end, if mv remains 0, we will return d, which means we have to exit from the rightward side. So I j minus 1. If mv is 1, will move from the upward side. Move row by one, up step. Yeah. Now, if again MV remain at 2, MV remained at 2, we will return what? We will move towards the rightward, which means we have to exit from the rightward direction. So I j plus 1. Now, again, if MV is 3, MV is 3, in this case, we'll move from the downward direction. That is what it is remaining. I plus 1 j. Let me submit and check the efficacy of our solution of our approach. Yeah, as you can see, it does the job pretty effortlessly in very less time. Okay. I hope you enjoyed it and learned a new concept. Thank you. Have a very nice day.